Hello, Augies Worldwide. I'm Dave Kassler, amateur radio call sign KE0OG, here with another episode of Ask Dave. Today we're going to talk a little bit about RF exposure. We have a question here from Brent Johnson, KI5HXM. And he's been working with the calculator that's on the ARRL website. And I'm going to bring that up right now. Okay. We have this up on the web. This is arrl.org/RF-exposure-calculator. Okay. And this is something that can be done with the whatever radio you have. And in fact, you need to do this now just to make sure you're okay. The parameters, power and antenna. It's just easiest to assume that this is the power to the antenna at the feed point. It's, I think, most conservative to assume that there are no losses getting there, okay? Now, under some conditions, there will be. If you need to get that technical, you can do that. But let's say this is a 50-watt mobile rig. Now, the duty cycle is FM. Now, Brent had a little trouble with the idea that FM was 100% duty cycle. Well, what we're talking about here is the RF waveform, not the audio waveform. Unlike SSB, which transmits nothing if there's no audio, FM is always transmitting at full power. And the way you modulate the RF is by modulating the frequency. Okay? So the actual duty cycle is 100% because the carrier is always on full power. And you modulate the frequency of the carrier to carry the audio information. So it really is 100%. So now we're going to go here to transmit duty cycle. You transmit for 5 minutes and receive for 10 minutes the antenna gain. Now, if what you have on your roof of your vehicle is just a simple quarter wave like that, the gain is, let's see, it's in dBi. Okay, so it's going to be 2.15 to move it to a dipole or vertical. So we'll just call it 2.15 dB. Okay, 2.15. And the operating frequency, we're going to go 146 megahertz, okay? Now, we're going to come down here and calculate this, and we find that the maximum allowed power density at that frequency is 1 milliwatt per centimeter squared. The minimum safe distance in feet is 3.8, so let's say 4. The minimum safe distance in meters, the minimum allowed power density is 0.2 milliwatts per centimeter squared. So the minimum safe number of feet is 5.47. This is for an uncontrolled environment. And safe distance, that's meters. Now, the difference between a controlled environment is that everybody there knows you're transmitting, and they have an idea to stay away from your antenna if you're transmitting. That's not very many feet, so if it's up on your roof, you're in like flint. You have no trouble. But if it's on the roof of your vehicle, and you're at a public event, for example, you're helping out with communications, emergency communications at a race or a run or a civic event or whatever it may be, okay, this is the uncontrolled environment because people around you don't know anything about RF safety. So in a controlled environment, 3 feet, but in an uncontrolled environment, 5.5 feet. Now his question is, what happens if you're in a vehicle? So I'm going to draw one of my usual lousy drawings of a vehicle. Okay, and you're inside here. And your vehicle's over here, and your antenna is in the middle of the roof. Now, clearly, you are less than 5 feet from that antenna. So what do? Well, here's the thing. If this is a mag mount antenna, okay, and it actually magnetically attaches itself to your roof's surface, you can bet that you are dealing with a metal roof. Not all car roofs are metal. Some are plastic. If it's a convertible, it's even fabric. Okay? So this acts as a shield. Okay? A shield. That protects you and the other occupants of the vehicle. Now the radiation goes out and the hazard is 5 feet in all directions. So you want to either like park really close to a friend's vehicle or something on both sides, or put tables out here, you know, like for putting literature out and so on. And you will find that people cannot get within the 6 foot radius around that antenna. So that solves that problem. This metal shield does indeed act as an RF protector. Now what happens if you go to put your mobile antenna on the roof and it doesn't stick? Well, it's not a metal roof, and you're not going to have any luck using this as a ground plane for your antenna. So you're going to have to go to something different, like setting up, running a coax out and setting up on a tripod a J-pole. Now what does that do to you? You're going to want to put cones around this thing 6 feet away from it. Okay? And some sort of a, one of those, it's not a police tape per se, but it's a do not cross kind of tape around it at 5 feet away from it. Okay? And then you want to be more than 5 feet away from that. And then you, in your controlled environment, are okay because you're actually okay within the controlled, uncontrolled environment here. All right? So you're in good shape. This is a very common scenario at an event. And if you can set that J-pole antenna up on a tripod, put sandbags over this so the wind doesn't knock it over. Rather than use the antenna there, use the J-pole. They have about the same amount of gain, actually. This is a half-wave end-fed dipole. This is a quarter-wave vertical against a ground plane. Okay? So that should help answer the questions. While we're at it, let's just take a look at the RF calculator, shall we? Okay, let's take, say, 10 meters. Okay, we're going to put on 100 watts at 10 meters, and we're going to do it on sideband, and we're in a contest, so we're going to do a fair amount of speech processing, and we're going to transmit, we'll say again, 5 minutes. You won't transmit that long. You're going to transmit about a minute, and then receive for 10 minutes while you're looking for other stations. The antenna gain, well, let's suppose that you've got a nice dipole out there, or vertical for 10 meters, so it's still going to be 2.15 above. See, it says need help with this. It's got, tells you what to put down in there. Okay, so let's go back. The operating frequency is now 28.5, which would be a good one. We'll calculate, and now we'll move down here. Note, the 100 watts will give you maximum safe distance. Now, there's something very important about this calculator that it doesn't show on the calculator, and I want to show here on the whiteboard. The calculator does not give this directly, but if you have an antenna and it's say a quarter wave high and you've got radials and stuff like this, the first quarter wave out here will be what's called the near field. The near field is where all the different waves coming off that antenna sort themselves out and create horizontal wave fronts going out. They're actually spherical wave fronts coming out from this antenna. Now the near field for an antenna without gain is about a quarter wave, but if this antenna has gain, for example, a Yagi, okay, this has gain that extends the near field. And you can look in the handbook and see how far that extends the near field. But what this tells you, as we turn back to the calculator here, is that from the far field point of view, we've got milliwatts per square centimeter, not very much. Minimum safe distance, 1.64 feet. So actually, not very much. Okay, for an uncontrolled environment, 2.84 feet, not a problem. All right, so this doesn't take into account the gain so much. Let's put some gain into this antenna. Let's add a 10 dB from a beam, okay? And we'll calculate that. Now we're up to 9 feet, still a nice safe distance and so on. So you can print the results from this and keep this in your logbook, okay? And if your neighbors complain about your antennas, that they are affecting them, you can take this over to them and say, this is the maximum allowed, what it will be, and that your exposure will be less than this, okay? Now, if one of your neighbors says, well, I've got a pacemaker, or I've got some very sensitive equipment like a oxygen generator or something like that, you can give them the values of maximum safe distance for an uncontrolled environment for your setup. If you were to add, let's say I'm going to go up to 500 watts, because I have a 500 watt amplifier. Okay, and I'm going to, whoops, I don't want to print the results, I want to calculate the results. Okay, it goes up to 20 feet. 20 feet, well, it depends if they are 20 feet from your antenna. Okay, they are at the minimum distance away from your antenna. You may end up having to make sure that you do not point your beam at that house unless you are sure they are not there. Or point at other places, or use lower power. 10 meters happens to be kind of a weird frequency, because 10 meters, the half wavelength is 5 meters, and humans are about 2 meters tall, so you can see where you're starting to get into where you're going to get some sort of resonance with the human body. The VHF figures are higher because 2 meters is the height of a human, and a human can act as an antenna, as a dipole for that. So, in any event, that gives you just a little quick idea. If you are in a car or truck that has a metal roof and your antenna is on the top, that metal roof is most likely, in all likelihood, protecting you from RF exposure hazards when you're in the truck. Now, what do you do if you're using a 10 watt handheld? Let's check this one out. Okay, we're going to go up here to 10 watts. That's this new Radiodity rig I just received. It's FM again. Okay, transmit cycle, and you transmit for, you're probably going to make a comment that's going to be about 5 minutes, and you might listen for 10 minutes and hear others and so on. Your antenna gain is, I'm going to put just 2 here because it's actually less than a dipole by a whole bunch. And the operating frequency is 144. And we'll calculate 146. Let's do 146. Okay, and we're going to calculate that. Okay, and you're only going out a couple feet. Now here's the safe distance for those in a controlled environment. You are in a controlled environment because you know all about the radio you're operating. Kind of hard to operate a radio without knowing that you're operating a radio, okay? So this says 1.7 feet. So I'm going to take this new Radiodity radio. Put the antenna on, and I'm going to hold this about 1.7 feet away. Okay? This is where it needs to be operated. If you're any closer than this, you have a radiation, RF radiation hazard to your brain, eyes, upper body, and so on. Okay? Now, does anybody operate their handheld like this? No. Now, there are millions of handhelds in the United States operated by public service agencies. Some public service agencies operate it like this, so that the RF's out here, or they operate it like this, or they might operate it with their left hand like this, okay? So there are different ways to do it to keep that antenna away from you. The other way you can do it is with a speaker mic, and keep the thing out here and use the speaker mic that has a speaker in it so you can hold it or up here where you can listen very well, or you can have it on a shoulder clip or something like that. So yes, these do represent an RF exposure hazard, and I would recommend you, unless you only operate your handheld very infrequently, that you go ahead and do it. Now remember what the problem is with RF exposure in the human body. It's non-ionizing radiation. To become ionizing radiation, it has to go up to like ultraviolet, okay? And we don't get anywhere near there. Okay, the thing that causes the burning on our skin from the sun is the ultraviolet. It actually attacks the skin and burns it. And it actually is an ionizing radiation, and eventually with lots of exposure to the sun, you can get skin cancer. This won't do that. The mechanism for radiant energy here is that it is going to cause body heating. Now, the easiest thing to do is ignore it. Of course, your skin is your radiator on your body, and your blood is the thing that carries heat from the hot spots down to the cooler spots, and your body starts to sweat if it needs a little additional cooling. If it goes beyond that, then you are actually in danger of heat stroke and things like that. That would come from the sun on really, really hot days like we've been having this summer. I guess it's, as of about an hour ago, it's fall. Okay, so happy fall to everybody. Spring in the Alaska and New Zealand. So anyway, so there you have it. We've learned all about some RF radiation from Brent's question here, which came in on my website as a comment to the RF exposure amateur extra class lesson 11.2, which talks about RF exposure. So metal can block, like a metal roof. And make sure it's not a plastic roof with just a metal beam over the top. Make sure that it actually is magnetic all the way around there. Okay. And then that will protect you from what's happening inside. If it's magnetic, it'll probably be steel. Most cars are made of steel, although there's a lot of plastic in today's cars. Okay. So, I would like to tell you about the giveaway that's current right now, and the giveaway is here. And I'll put this down here so you can see it. The giveaway is an antenna. This is giveaway number 2. And the closing date for having your entry to me, and the entry needs to come in this form. This is a postcard. Okay, it's got my name on it. Here, we'll just put it down here. It's got my name on it. Okay, to P.O. Box 98, Ridgeway, Colorado. And then I need your shipping address, okay? And your name, shipping address, call sign, and I don't need your email address, but I do need your phone number, which this doesn't have. I need your phone number in case I have any questions, okay? So make sure you include your phone number with that. The giveaway will be September 30th, 2021. So if you're viewing this right now and it's after that, go look at a more recent video and find out what the giveaway is then. The giveaway is an end-fed half-wave 80 through 10 1K myantennas.com antenna that covers a slice of 80, the bottom end of 80 where you can do FT8. All of 40, 30, 20, 17, 15, 12, and the bottom part of 10 meters, okay? The wire length is 130 feet, so you've got to have a little room to put this in. You can hang the ends down. It can handle up to 1 kilowatt of single sideband, okay? Or for that matter, CW, but not for longer. You'll start to melt things. If you do FM on 10 meters, it's going to melt something, okay? Stainless steel hardware, silver Teflon SO239s. It's got a place here for counterpoise if you need it. Your coax, I connected it with a piece of 50-foot coax. And then this thing stretches out here. I put it up as an inverted V, and it looks fine. So there you have that. If you would like to contribute to this channel financially, you may certainly do so by going to dcasler.com/support. There are several ways there that you can do it. One that I'd like to highlight is Patreon. In Patreon, what you do is you sign up for a certain amount per month, and there's really no limits on that, and then you are a patron of this channel. Now, one thing that my assistant does when he makes these videos is he picks one a week to go up early onto Patreon. So you can actually watch it on Patreon a week before or a few days before the rest of the Augies get to watch it. So that's one of the privileges of being a patron. Also, please check like and subscribe. I'm getting very close to the 100,000 mark. And the big deal about that is I get a nice plaque from YouTube. Looking forward to that plaque. Worked hard for it. So until we next meet, 73.